Alright, we're going to look at section 2.3, which is adding real numbers. And you'll see as we go through this expression that what we're really trying to get at here is the idea of adding sign numbers, so dealing with both positives and negatives. And we're going to start off with just getting used to some of the notations involved with negative numbers. So they're asking us to simplify a few things in this example. So how would you simplify the negative of -4? Well, one way that I have found is useful to think through that is read this front negative as an opposite. So what is the opposite of -4? And I think when you say it that way, most people go, okay, the opposite of -4 is +4. And I think ultimately you want to just remember a rule there, which is that if you have a negative together with another negative, those two will always cancel out and you'll get the positive. So this negative and that negative cancel out and we get A, or in words, the opposite of a number is equal to that same number. One trick that I thought was kind of interesting that a student showed me once that was a visual thing is we kind of have this idea in words that if you have these two negatives they're going to cancel out and make a positive, but what the student showed me was they used their fingers to represent these two negatives, and they said if you have two negatives and you put them together you get a positive sign. So I thought that was an interesting visual way to remember it. If you have two negatives, they're going to go together and they're going to make a positive. So if that helps you remember, that's great. Alright, let's look at B and C where we're dealing with the idea of absolute value. So we want to look at the absolute value of -8 and the absolute value of 6. And if I was just going to ask students this question without telling them what to do, and I said, what is the absolute value of -8? I almost always get the right answer from people, and they would say that it's 8, that absolute value got rid of that negative sign and changed it to a +8. However, when I ask people what's the absolute value of 6, a lot of those students who got this one right will say that it's -6 here and get it wrong. The absolute value of 6 is in fact just 6, just like what we have inside. And the reason for that comes from this definition down here. The absolute value of a number is the distance from that number to 0 on the number line. And when we measure distances, we never report a distance as negative. So this number, -8, is 8 units to the left of 0 from a number line, but the distance, whether it's left or right, we would say is 8 units. And this number is 6 units to the right of 0 on the number line, but again, we don't care if it's right or left when we're doing absolute value, we just want to know how far is it, so we would say 6. So absolute value does not change the sign of a number. The absolute value gets rid of negative signs on numbers. If the number inside was already positive, it just stays positive. And it wasn't listed here, but I'll just add this on. If you have the absolute value of 0, that would turn out to be 0. So the absolute value treats these positives and zeros in the same way. It just kind of spits out the same number. But if it was a -8, then it's going to change signs and become a +8. Alright, let's discuss the idea of addition with sign numbers a little bit now. So they want us to add -3 plus -2. And again, most of you probably already know that answer. Hopefully you even know it right away. And I'm going to write that answer down. -3 plus -2, most of us know the rule there. It's going to be -5. But I want to show you where that rule comes from on the number line. The idea would be that we take a number line, we put 0 on there, and we say, alright, we're starting at -3, so we're 1, 2, 3 units to the left of 0. And then we're going to add a movement of -2 onto that. So from that spot of -3, we're going to move 2 more spots to the left. So where would we be now? At -3, -4, looks like -5. So 2 movements to the left, we would add those movements up and then keep the negative to report that we ended up on the left-hand side. Now it works out a little bit different when the numbers are opposite signs. Let's start off with the visual on that one as well. So I start out at 0 and I go 1, 2, 3, 4 units to the right, and that's where I'm starting. And then I'm adding -7, so I would think of that again the same way, that I'm going to move from there 1, 2, 3, 4, 5, 6, 7 spots to the left. And the first 4 movements just get me back to 0, but the next 3 send me into negative territory, -1, 2, 3. And so the answer here would be -3. Now you could work that out on the number line all the time, but that starts to get kind of tedious when you're dealing with things like 17 plus -14, where you have a lot more movements, or things like negative 3.7 plus negative 9.9 where you have messy distances that you're moving. So we really want to come up with rules here, and we'll report those rules on the next page. But if we just start thinking about them here, it looks like if you're adding things with the same sign, you would just add up the absolute values of those numbers and say 3 plus 2 is 5. And then whatever that common sign was, that would go on your answer. And again, that makes sense on the number line. If both moves were to the left, you end up on the left. Here, if you look at where's the 3 coming from, you could say 3 is the difference between these instead of the addition. And when I say these, I actually mean the absolute values. So between the difference of a 7 and a 4 would be 3. Why the negative? Because our bigger movement was to the left, so the left wins out. And that is part of our rule, that when you have opposite signs, you subtract the numbers, and the one that has the bigger, that absolute value, is the one whose sign wins, so that negative is part of our answer. So we would apply that same rule right here and say we have a positive and we're adding a negative, so what I really want to do is take the difference. And when you think about the subtraction, always just do the big one minus the small one, and then think about out front, okay, but what sign is it going to have? Well, the bigger number is 17, and that's a positive, so that's going to win out, and it's going to be a plus. And the 17 minus 14 is 3, and we don't usually write a plus in front of our positive answer, so I would just write 3. And then finally, negative 3.7 plus negative 9.9. I wouldn't do this on the number line, but I would think about it on the number line. This is starting on the left and then moving more to the left. Both movements are to the left. So I add a movement of 3.7, and then I'm adding another movement of 9.9. Doing the work here, 7 plus 9 is 16. Carry the 1. Looks like we would get 13.6. But that's how far I moved. Now, what direction did I move? I moved to the left both times, so my answer would actually be negative 13.6. I'm just going to draw a little line here to kind of separate out my scratch work where I was doing the addition from the answer to the problem. Okay,